so it says, based on our current knowledge of derivatives, how would you find the derivative of something like y equals 3x minus 2 squared? So right now, what we would do is we would FOIL it out, right? So we would say, okay, well, y is going to be 3x minus 4 times itself, which ends up giving us 9x squared minus 12x, so minus 24x plus 16. And then when we take the derivative, we would end up getting 18x minus 24. Okay. But if we had something that looks like f of x equals 3x minus 4 to the 15th, we don't want to FOIL that out. That would take you all day. Like, that would take a really long time. So we use something called the chain rule. So it's a really easy concept, but it kind of is like W substitutions that you learned in Algebra 2. Okay, so basically what we would do up here with the chain rule is we treat our 3x minus 4 as if it's a u. So we say, okay, well, we had y equals 3x minus 4 squared. So it's in the form y equals u squared. And then we take the derivative of u. So we're like, okay, well, that means y would be 2u. But when we do this, we would end up getting y prime equals 2 times 3x minus 4, and there would be an error because this only makes 6x minus 8. And as you can see over here, we have 18x minus 24. It's not the same thing. So the thing that we are missing is what's called the chain. So we would need to multiply by a 3 to get our actual answer, which is 18x minus 24. And so what the 3 is the derivative of the inside part. So the part that you let be u, you take the derivative of that u, right? So the derivative of 3x minus 4 is just 3, and you tack it on to the end. So sometimes the chain has x's and so on, but that's a pretty basic chain. And the reason that we do this, so I guess it says look for the inside part and set it equal to u. So therefore in this problem, we would have u equals 3x minus 4. Then we'd have to take the derivative of u to the 15th, which is 15u to the 14. But we also need to multiply by the derivative of u. So I always say multiply by the derivative of what's inside. So it's always like a kind of like an invisible parenthesis or a parenthesis, okay? Yes?
Why was u only 3x in the first one, but it's the whole thing in the second one?
It's not the whole thing. It's just this here.
Yeah.
That's the u. So it's u to the 15th there. All right, so why do we do this? It's just like unit conversions in chemistry classes, okay? So, I know, you love unit conversions. So if you have dy over dx, we read that as the derivative of y in terms of x. That means if we had like we had, I don't know, I'll just make another example. I don't remember exactly what it was. If we had something like that, this is all like f of, like y is like a function of x, right? It's like an f of x function. Do you guys understand what I'm saying there? So what we do is we temporarily change it so it looks like a function in terms of u, and then we take the derivative of that. So we say, oh, that's going to be 15u to the 4th. But then we also have to consider that u was a function of x. U was 5x minus 3, so we take the derivative of it in terms of x, which would be 5. Okay, so with unit conversions, do you guys remember when you would have things like, oh, I have feet per second, but I don't want feet. I want to change it to miles. So we would do miles and feet, right? So we'd have 5280 feet in a mile. That's what we're doing here. Do you guys see how the du's basically cancel each other out? And we get it. Okay? So derivatives are rates of change, and they are very similar to unit conversions. All right, so there's kind of a complicated definition here. It says if f and g are differentiable on their domains, then the composite function, right? Remember f of g of x from Algebra 2 in pre-calc, is differentiable, and it's given by the product f prime of the inside times the derivative of the inside, so g prime of x. Okay, so you will need to know this formula. You'll get used to using it though, so it's not really one that I would like really focus on memorizing right now, but we're going to use it a lot with chart problems in particular. Okay, in Leibniz notation, just like we said, it would be y is, you're going to take the derivative in terms of u. G, you're going to take the derivative in terms of x. Or u is the derivative in terms of x. So that's why the dy over dx looks like that. It's two separate pieces. All right. So first I want you to identify what the inside part is for each function. Okay, so the inside part for number 1 is what part? 2x minus 4. So this is in the form the square root of u. Okay, I'm not going to make you rewrite things as u and so on. I'm just going to always remember that you take the derivative as if it was u to the 1/2, right, the square root of u, and then you multiply by the derivative of the inside part, the derivative of u, okay? So if I was rewriting this one so that I am able to take the derivative, it's 2x minus 4 to the 1/2, right? That's what it means. So when I take the derivative, f prime of x, I'm going to have my 1/2. I treat that inside part as if it's one variable, like u. So I say, okay, that's still 2x minus 4. Raise the negative 1/2, and then times what? 2, the derivative of the inside, exactly. So this you can clean up a little bit. The 1/2 and the 2 will reduce out at least. So you could write this as 1 over the square root of 2x minus 4. So many people are tempted when you see something like number 2, when you see sine squared x. They're like, oh, the derivative is going to be cosine squared x. But that's not what it is, okay? And I think some of you guys saw that on your homework when we had the chain rule, or the product rule. You could think of this as sine of x times sine of x and use the product rule. So that would be one way of doing this. But the second way would be to think of it as y equals sine of x, all of it squared, right? And then use the chain rule. So we're going to go ahead and use the chain rule. Okay, do you guys understand that notation, how I wrote it? So when I see that, y equals sine of x squared, what's my u? Sine of x. So it is in the form u squared. Do you guys see it? So if we have u squared and I'm taking the derivative of u squared, it's just going to be 2 times u to the first, right? 2u. So my derivative is going to be 2 times my u to the first, and my u is sine of x. But then I always need the derivative of the inside. So what's the derivative of the inside? Cosine of x. That one's bothering me there. So our answer is going to be 2 sine of x cosine of x. All right, you would get the exact same thing if you did the product rule. Okay, but again, there's some convenience. What if you had y equals sine to the 10th of x, right? That's why we learned the chain rule. Okay, so some things you can do with the product rule anyway, but some things a little bit harder. Do you guys know what the derivative of this would be? 10 sine of x to the 9th times cosine of x. Exactly, good. All right, so number 3. So this looks almost identical. When I read it, I say sine of x squared, right? But not sine of x in parentheses all being squared. Do you guys see how this is different? So what's the u in this one?
X squared.
It's x squared. So we're thinking of this as, so it looks like sine of u. Well, how do I take the derivative of sine of u? I would do cosine of u, right? And we always tack on the derivative of u, du. All right, so I'm going to do f prime of x is going to be, the derivative of sine of u is going to be cosine of u. So I keep that u value the same. And then I multiply by the derivative of the u. So the big thing that people will mess up is this is still just u. And then this one is the derivative of u. So every year that I teach this, people just want to say that it's cosine of 2x. Does that make sense? They do like a combination of the two things. So you're tacking on at the end the derivative of the inside. All right, so the next one, you guys are all pros at this now, aren't you? 100 x cubed minus 4x plus 2 to the 99 times. Okay, so the way that I've written it right now, everybody look up here, would be incorrect. You would get this wrong on the AP test. You need those parentheses. So you need to multiply by the entire derivative of u. Does that make sense? Because otherwise you're just multiplying the 3x squared by that first part. There's not much you can do to clean this one up, so I would just leave it like that. Okay? How about you guys try number 5? So first rewrite it. I would not use the quotient rule. There's an easier way than using the quotient rule. So when you guys rewrite this, did you do x squared plus 1 to the negative 1/4? Did you all do that? Good. All right, now take the derivative. All right, so you should get negative 1/4 times x squared plus 1 to the negative 5/4 times 2x. Everybody have that? So could you clean this one up a little bit? Yeah, the negative 1/4 and the 2 could at least reduce down. So I would probably just write it as negative x over 2 times x squared plus 1 to the negative 5/4. And don't worry about writing things with like the roots and so on. You can just leave it like that.
Where did you get the, oh, from multiplying the one plus
So I just kind of combined this and this. All right, now this would be one that I would use the quotient rule on. Do you guys see it? But it's the quotient rule with the chain rule. So that's where things start to get a little bit complicated. Yeah, you knew it would get harder, right? So we're going to write it as 5x over x to the 5th minus 1 to the 1/3. Now, could you do product rule and chain rule instead? Yeah, you could do product rule and chain rule. So you could even write as 5x times x to the 5th minus 1 to the negative 1/3. So if you want to do it that way, you can do it that way as well. All right, so do you guys want to do quotient rule or product rule? Product rule. So this one would be quotient rule, so write yourself a note. And this would be product rule. Okay, so let's say we do the product rule. So we're going to have the first is 5x times the derivative of the second. So the derivative of x to the 5th minus 1 to the negative 1/3 is going to be negative 1/3 x to the 5th minus 1 to the negative 4/3 times 5x to the 4th. Then we do plus, the derivative of 5x is 5, and then we keep the second part normal. So x to the 5th minus 1 to the negative 1/3. So there is a little bit of cleaning up that you could do. I'm not going to do it, but basically you could combine these and these. So simplify a little bit. All right, we'll skip it. All right, so let's try number 7. So same idea on number 7. So identify what the u is. What do you guys think the u is on number 7? It's tricky. Yeah, the u is this 1 over t squared minus 2. So when we do the derivative of u, we're going to use the quotient rule. Or you could use the chain rule if you wrote t squared minus 2 to the negative 1/2. So a double chain. Right, so we'll go ahead and do the quotient rule for that. So this is in the form the square root of u. So do we know how to take the derivative of the square root of u? Yeah, it's u to the 1/2, so its derivative is going to be, so let me write it as, so I have 1 over t squared minus 2 to the 1/2. So its derivative is going to be 1/2, the u value to the negative 1/2, times the du. So I'm going to have 1/2 times 1 over t squared minus 2 raised to the negative 1/2 times, and this is going to involve the quotient rule. So our derivative of u, so here's where u is. Okay, we would do low, d high, so d high is lucky because it's 0, minus high is 1, d low is 2t, all over the square of what's below, 2t minus 2 squared. So that one could definitely use some cleaning up.
For the y1, why didn't you multiply on the end by 1 over t squared minus 2?
1 over, what was it?
Like, don't you have to multiply by the inside when you're doing the derivative?
The derivative of the inside. Yeah, so the derivative of the inside is that part that has the quotient rule underneath of it. The du. All right, so if I was going to clean this one up, when I have this negative 1/2 thing, that's kind of weird. I have a quotient that's raised to the negative 1/2. So if I have 1 over t squared minus 2 raised to a negative 1, or a negative exponent, do you guys see how that flips it off? It's kind of weird. So you would actually have 1/2, and then you'd have t squared minus 2 to the 1/2, right? And then this part becomes 0. I get times negative 2t all over t squared minus 2 squared. So I know I kind of skipped simplifying the last one, but it is important to know how to simplify things because, surprise, your AP test has multiple choice, right? So sometimes the answer you get looks nothing like the answer that they have, and you have to kind of move things around and simplify. So what if I have t squared minus 2 to the 1/2 on top, and I have t squared minus 2 squared on the bottom? What will I be left with, and where will it be, top or bottom? It's t squared minus 2, not to the 1, but it'd be 1/2 minus 2 would be negative 1 and negative 1 and 1/2, which is negative 3 over 2. So I'm going to put 3 over 2 on the bottom. Do you guys see that?
How did you get that?
I have 1/2, like if I had x the 1/2 over x the 2, we subtract our exponents. So I'd have like 1.5 basically, but it'd be on the bottom. All right, so, and then I have 1/2, and I have negative 2, so I'm going to get negative 1t on the top, and that's probably the form that they would put it on the AP test. Yeah?
So why didn't you have to use the quotient rule for 5, but then you didn't have to use it?
For number 5,
Just, yeah, like why you did and didn't have to use the quotient rule.
because the u for the number 5 was x squared plus 1, so it doesn't involve a quotient. But the u for number 7 is 1 over t squared minus 2. So it's a quotient. All right, so this next one. So what I would do is you could rewrite it as negative 1 times the square root of x plus 1 to the negative 1/2, or not negative 1/2, negative 1. Or I would just use the quotient rule on this. So if you're going to use the quotient rule, there's actually not even a chain in it then. So your quotient rule would be low, d high, the derivative of negative 1 is 0, minus high is negative 1, d low. So what's the derivative of the square root of x? It's x the 1/2, right? 1/2 x the negative 1/2. I want you guys to get to the point where you see square root of x, and you know right away that it's 1 over 2 root x. Do you guys see how it's 1 over 2 root x? Because if this is x the 1/2, then its derivative is 1/2 x the negative 1/2, so it puts the square root on the bottom. Can you guys know that one right away? All right, so we have that, and then plus the derivative of 1 is 0, so that was gone. All over the square root of x plus 1 squared. Now don't get fancy and try to bring the square in. It's not the same as x plus 1, right? You'd have to like FOIL that out if you were going to find that. So I think the only thing I would do here is kind of simplify the top. So I get positive 1, and then I have 1/2, and it's 1 over square root of x. So I'm going to do 1 over 2 root x divided by square root of x plus 1 squared. So I probably wouldn't leave that as a fraction within a fraction. So you guys are going to get good at doing these fractions within fractions. But basically we have 1 over 2 root x divided by that whole squared part. So do you guys see how the squared part's going to go on the bottom and the 2 root x will go on the bottom? It's like 1 over as you flip it. So we're going to get 1 over 2 root x times the square root of x plus 1 squared. And you could FOIL out that part, but I would just leave it like that. Yeah. Because if I had something in here, then when I flip it and do multiplication, I do 1 over that. So it should be a 1 on the top. With me? Do I need to do an easier example? How did I get a 1 on top? I don't know. Like from here, is that what you're saying? I combined these, so I said, okay, I have negative 1 times negative 1 is 1. And then I have times 1/2, and then x the negative 1/2 puts it here on the bottom. Like when you have 1/2 x the negative 1/2, it is 1 over 2 root x. That's what I'm rewriting it as. And that's what I was telling you. If you guys just know that, it will save you a lot of work instead of writing it as 1/2 x to the negative 1/2 every single time. So we get that. All right, so try the next one. So you're going to find the derivative, then you're going to plug in the point to find the slope, and so on. So try that. Okay, good. I still have 2 minutes. Oops. All right, so check your derivative. You should have 1/5, 3x cubed plus 4x raised to the negative 4/5 times the derivative of the inside is 9x squared plus 4. Did you guys all have that? All right, so now here's the tricky part. If you find the slope, you need to plug in 2. So it looks kind of like a hot mess at first. So we have 3 times 8 plus 16, right? Or not 16, plus 8. 4 times 2 is 8. Raised to the negative 4/5 times 9 times 4 plus 4. And we simplify. So I see many of you guys pulling out your calculators. Let's see if we can do this. So I have 24 plus 8 is actually 32. So I have 1/5, and then I have 32 to the negative 4/5. So I know this breaks your heart, but as I've told you, 2/3 of the AP Calculus test is non-calculator. So you need to know how to do this without a calculator. So if you have 32 to the negative 4/5, this is why we do these things in like Algebra 2 and Pre-Calc and so on. So what that means is 1 over 32 under a 5th root raised to the 4. What does that become? 1 over 16, exactly. So I have 1/5, 1 over 16 times 40. So I get 40 over 90. Is that 90? Yeah. No, 80. 40 over 80, which is 1/2. So that all simplifies down to 1/2. So that's our slope. And then we have the point. So our equation is going to be y minus 2 equals 1/2 times x minus 2.
Where'd the 1 over 16?
From here. The 5th root of 32 is 2. And then 2 to the 4th is 16. All right, a couple more. So let's skip part B. It's the same idea. You would first rewrite this as all of that to the 1/2, and then you would do the chain rule, right? So you'd have 1/2, all of that on the inside to the negative 1/2 times the chain. All right, so let's try one where we have these numbers. So this is a little bit more like theoretical, like, wow, how do I do this without actually having the function? So let's think about it. So if you have y equals f of x cubed, what I tell people every single year is to think of f of x as being sine of x. If you guys had sine of x cubed, you totally know how to take the derivative. What would we do? 3 sine of x times, or 3 sine of x squared times cosine of x times the derivative, right? So the derivative here is going to be 3 times f of x squared, right? So we kept the f of x exactly how it was, just like we kept sine exactly how it was, times the chain. So the derivative of the inside is going to be what? F prime of x. Do you guys see that? Now we're plugging in. So we're going to find at 2. So I'm going to have y prime of 2 is going to be 3 times whatever f of 2 is squared times whatever f prime of 2 is. So let's see, f of 2 is negative 3, so I'm going to have 3 times negative 3 squared, and then f prime of 2 is 6, so I get 3 times 9 times 6. What is that? 162, thank you. All right, or the next one, if I have f of g of x. So think of f of x as being like sine and g of x as being something else. So what if you had sine of x squared? How would you take the derivative? It would be cosine of x squared times 2x. So when you see f of g of x, which is always on the AP test because that is the chain rule, it is f prime of the inside stays the same times the derivative of the inside. Okay, just like we were talking about here, it would be, its derivative would be cosine of x squared times 2x. So think of examples to help you sometimes. All right, so for finding y prime of 2, so we're going to have f prime of g of 2 times g prime of 2. So what is g of 2? 3, right? So we have f prime of 3. F prime of 3 is 4. G prime of 2 is negative 2. So your answer should be negative 8. C involves the product rule. We've done a couple like that. And D involves the quotient rule.
Where'd you get the f prime of 3?
I found G of 2. G of 2 is 3.
Oh.
And then I plugged it in.
How did you plug in for
F prime what?
Like before had the number for f prime is 6, so why?
Because I was finding f prime of 3, because g of 2 is 3, so f prime of 3 is 4. So you're not doing f prime of 2, you were doing f prime of 3, actually. All right, and then the last ones we have are multiple chains, double chains, triple chains, and so on. So as you work your way to the outside, you want to think about, okay, the inside of this was my u, and then this was my u, and then this was my u. So we're going to start like on the outside, kind of. So what we're starting with is sine of u. So if we do that, f prime of x is going to be sine of u, its derivative would be what? Cosine of u, right? So our u is going to be cosine of tangent of x. So we keep it the same. And then we multiply by the derivative of u. So it's like you're doing a two-part problem. So now you're saying, okay, now my equation is y equals cosine of tangent of x. How do I take the derivative of that? How do you think? Negative sine of tangent of x,
You would take the
but then times, last thing, derivative of tangent, which is secant squared x. Do you guys have those memorized yet? I didn't memorize those.
Why'd you keep the tangent and the sine? Like,
Because if I kept this as my y, it would be, this is in the form cosine of u.
yeah.
So it would be negative sine of the inside part stays the same times the derivative of that inside.
But I thought it was going to be like negative sine of x times negative secant. Times secant.
I know, but it's still, this is now the new u. It's like a w. And then this is like the derivative of w. It's multiple substitutions. Rough, isn't it? So this one would be, you would first rewrite, so you'd say, okay, this is sine of 2x cubed minus 1 quantity squared. So right now, this inside part is like that. So this is in the form u squared. Do you guys see that? It's in the form y equals u squared. A bunch of junk inside raised the second. So if I have u squared, how do I find the derivative of u squared? 2u, right? So I'm going to do 2, bunch of junk inside. So I'm going to do sine of 2x cubed minus 1. So that was my u, right? But I still need to multiply by the derivative of u. So like I was saying, it's like a second part of the problem. So you're thinking, oh, that u part now is sine of 2x cubed minus 1. So how do you take the derivative of sine of 2x cubed minus 1? You do cosine of 2x cubed minus 1 times 6x squared. Yeah, good. So those take some practice. They're hard.
Why did the squared on the sine go? Like when you rewrote it?
We took the derivative of u squared and it went to the front 2u. Remember, like derivatives. Yeah, Carolyn?
Can you just leave it like that?
Yep, you can leave it like that. Fun stuff, huh?